Several configurations inform the behavior, presentation, and documentation standards for mechanical systems in Revit, and one of them is mechanical settings. In this video, we'll configure the mechanical settings in Revit for duct and pipe systems. So open the file you used in the previous video or mechanical settings in the chapter 3 exercise files folder. So launch Revit, navigate to the exercise files. From the chapter 3 folder, open this file, mechanical settings, which I have here open. Next, go to the systems ribbon from the HVAC panel. Click the dialog launcher to launch the mechanical settings dialog. You can also type MS on your keyboard to launch the dialog. So quickly go through these settings we have here. The first we have is hidden line, and this informs the behavior of pipes and ducts when they cross each other at different elevations. It informs the line style, the inside gap, the outside gap, and also the double and single line representations. So to quickly show you how this works, I will create a duct. The first will be at say 27 millimeter, the minute elevation, and then I will draw another duct at say 21 millimeter middle elevation. So because these two ducts intersect each other at different elevations, you see this hidden line. So this is the inside diameter, this is the inside gap, this is the outside gap. And then when I change this view to single line by changing to coarse detail level, you also see the representation for single lines. So you can see the inside and outside gap and whatnot. So those are what you configure from this hidden line. It affects both pipes and ducts. The next setting we'll have here is the duct settings and the pipe settings. So these mainly inform the display of parameters on annotations like tags. So let's say I come here now, I create a pipe. So I draw a pipe at any elevation whatsoever, and this is currently, I can even use, so I tag this pipe. So by the time I tag this pipe, you can see the size is 150 millimeter, and this suffix for the pipe size actually comes from the settings that we have here. So if I go to pipe settings here, you see the pipe size suffix. So most of these settings here affect the annotations you find on annotation families like tags and whatnot. The same applies to ducts. However, when it comes to ducts, you have these two parameters, air density and air dynamic viscosity. They actually affect duct sizing and pressure drop for air systems. The next parameter or the next setting I have here is angles, both for ducts and for pipes. So this inform the fitting angles connecting the different ducts and pipe segments, and you can use any angle. You can set an angle increment, and you can also use specific angles. So let's say we use specific angles. So that means these are the only specific angles that we can use as angles between ducts or pipe segments. So let's say I create a similar duct. I select this duct and I create similar, and then I draw a duct at say 55 degree angle between the two, something like this. By the time I measure the angle between these two, this and this, you see that's currently 60. Why? That's because based on what we defined here, 60 is the closest to that 55 degrees. So it automatically uses that angle to connect the two ducts. The same applies to pipes. So you can use any angle or you can use specific angles when it comes to pipes. And then the next we have here is the conversion settings, and this informs the automatic layout of both ducts and pipes. So you can see you have conversion here for ducts, conversion for pipes. So basically every system has configuration for the main duct or the main pipe, and also for the branch duct or for the branch pipe. So you can see it's literally the same settings. Of course, when it comes to ducts, you also need to specify the flexible ducts if you're using that to finish off your system, and also the maximum flexible duct length, which we'll still look at much later in the course. Then the next we'll have is the sizes for the ducts. You have the rectangular, oval, and round duct depending on the shape of your ducts. So this informs the duct sizes, and for each size, there's the option to either include or exclude it in the size list, or during duct sizing, or even during automatic layout, which is also a kind of duct automatic sizing. So to quickly show you this, if I want to draw this duct now, you see that this is the size list. So any size I exclude or include from that settings is what, that's what determines what you see here. That's for size list. Now, if I draw this duct and then I want to use the automatic duct sizing tool, which we'll still look at later, you see the duct sizing tool here. So the sizes that you include or exclude from that setting will determine what Revit will use to automatically size the ducts. Of course, we'll look at this much later. The same applies to pipes. Then, of course, that applies to both rectangular, oval, and round duct sizes. Then for pipes, you have the segment and sizes. So this is a bit more robust than that of ducts, and that's because each segment has a catalog. You can see there are different catalogs here, and each catalog comprises the inside diameter and the outside diameter, and also you can choose to include or exclude them from the size list or for sizing. For each of them as well, you can set the roughness and even a description. You can even create an entirely new catalog or segment from here. So from here, you can define the material as well as the schedule type and whatnot. So you can see that you can define an entirely new segment from here for material, schedule type, and whatnot. Then the next thing that you have is fluids. So fluids inform the properties of the fluid that is flowing in pipe systems, such as water, propylene glycol, or ethylene glycol, and whatnot. Now each fluid as well has a catalog, as you can see from here, and you can configure the temperature, and the temperature informs the viscosity and the density. So you can see the dynamic viscosity and the density. Now, similar to air density and dynamic viscosity we saw earlier under the duct settings, recall we have this air density and dynamic viscosity. When you come to fluids under pipes, these two parameters as well affect pipe sizing and pressure drop. And as well, you can create entirely new fluids and specify their catalog and whatnot. And you can even delete an entire fluid from here. The next we have is slope, and the slope setting is for sloping pipe systems like sanitary and waste disposal, and those kind of systems are actually slopes. So here you can define the slopes. You can also delete slopes. For the ones you create, you can delete some of them, and even these existing ones, you can delete the slope from here as well. Then finally, you have calculation, both for ducts and for pipes. So calculation informs the way Revit performs various calculations for duct and pipe system. First, you can enable network-based calculations for duct system, and you can also choose the calculation method for pressure drop in a duct straight segment. So you can see the various options you have. So this determines how Revit performs a pressure drop calculation. So for example, we can say we can use Colebrook equation, and that will be it. The same applies to pipe. So here you can enable analysis for closed loop hydronic piping networks, and you can also choose the calculation method for pressure drop as well for pipe systems. You can also choose Colebrook and whatever you want to choose, And you can also see the flow, even though you have only one option here and whatnot. So for this, basically choose how Revit performs the calculations. So that's it. You can now configure the mechanical settings for your projects. It's imperative to include these settings in your firm's project template to ensure the same standard across your projects. As you can see, there are so many things to configure here. So after you've taken time to configure all this, make sure to include it in your firm's project template so that it becomes a standard across all your projects.